Hey everybody, in this video of the week, we're going to talk a little bit about function notation, and then we're going to do a couple of your homework problems. So function notation is something that math students tend to struggle with for a while. It's a little bit confusing at first, but here's an example. The way we read this is f of x equals 2x plus 5. F is the name of our function, x is the name of the variable in our function, and that's what goes in parentheses here. And what this says is that no matter what x we plug into the function, what this function is going to do with it is it's going to multiply it by 2, and then it's going to add 5 to it. So as an example, if I wanted to plug in x equals 3, I would use the notation f of 3, so I've just replaced x with 3. And I would also replace x with 3 on the right side. What the function does here is it takes the 3 and it multiplies it by 2 and adds 5. So we find that f of 3 equals 11. And what this notation tells us is that when x equals 3, the value of the function is 11. Now what does that look like on a graph? Well, it just says whatever this function looks like, at x equals 3, the value of it is going to be way up here at 11. And you've studied lines from the previous chapter, so you actually know that this line's going to look something like that. Passes through the point 311. But that's not really the point of this chapter. The point of this chapter is going to be dealing with and understanding function notation. So the question I always wondered about was, why do we have this f of x here? You know, teachers always told me this is not multiplication. And they're right, this is not a multiplication of f times x. This is just notation that says f is the name of our function, x is the name of our variable. But why would we do it like that? And I guess to answer that question, you'd have to look at some more advanced math. But here is an example from this class that I think applies. Here's function notation that you're going to see later in this class. This is for a quadratic function. And as math gets more and more advanced, you'll notice you see fewer and fewer numbers and more letters. I look at this function over here, and I see a lot of letters. There's A, there's X, there's B, and there's C, and it's a little bit confusing as to what's what. But the notation here says, well, the name of our function is f, and our variable is x. So that tells us that right there, that x and that x, those are our variables, and that means that A, B, and C must just be constants, or parameters. The only thing that changes in this function is x. That is why we use the notation that we do for functions. So I hope that that explanation helps you out a little bit, just in your understanding of why we write it like this. Now, I would like to take just a couple of minutes to take a look at one of your homework problems, and I'll show you how to enter your answers here. So this question is, determine the intervals on which the function is increasing, decreasing, and constant. So when we say increasing and decreasing, we mean the value of the function, that's the y value of the function, from left to right. So as you follow my cursor here from left to right, you'll notice that the function is increasing in value, meaning its y value increases here. Then you'll notice that the function starts to decrease. The value starts to decrease. Then you'll notice that the function becomes constant, meaning it doesn't change. Then continue to follow my cursor, and this function continues to increase until its value goes all the way up here. It looks like a little bit between 1 and 2. And then from there, the value of the function stays constant. So let's start answering the question. List the intervals on which the function is increasing. What this means is we want to list the x values for which the function value is going up. So what are the x values for which this function is going up? Well, it looks to me like since this arrow is here, this function continues to go like this forever. So from left to right, this function is actually increasing for all x values, all the way from negative infinity, all the way up to, when we get right here, the x value is -7. So I'm going to enter that in. If you click in this box, you get a few options down here. I'm going to click more so we have all of the possibilities. You could use this button right here to give you your interval. I'll delete that. You could similarly just type in parentheses. So our first interval where this function is increasing goes from negative infinity all the way up to -7. So negative infinity is this button right here, comma, and I can just type in -7 and parentheses. Now for what other x values is this function increasing? Well, it looks like between here and here the function is increasing. And if we talk about x values, those x values are just -2 over to -1. So I want that interval in there as well. And the technical way to do this is to use a union to combine two intervals. That's that button right there. And I'll type in the interval -2 to -1. And that should be the answer. Now, a lot of students ask, rightfully so, why I don't include any of the endpoints. Why am I just using parentheses instead of brackets? Well, the answer is a little bit different for each one of these. We never include infinity or negative infinity in our intervals. You'll notice at x equals -7, the function is changing. It changes from increasing to decreasing right at that point. So we don't include that in either increasing or decreasing. At x equals -2, you'll notice that there's kind of a break. And this is where the function goes from being constant to increasing. So we don't include that in the interval. The same story is true for x equals -1. So I'm going to hit enter, and this should be the right answer. Fantastic. And we want to list the intervals in which the function is decreasing. So again, we're looking at x values. So the function decreases here, and the x values there are from -7 to -5. I'm going to type that interval. Now, does the function decrease anywhere else? I don't think so. So I think that's it. I'm going to hit enter. Excellent. And on what intervals is the function constant? Well, the intervals we mentioned were right here and right here where the function stays constant. That's the y value of the function stays constant. And those x values are from -5 to -2 and from -1 all the way out to infinity, it looks like. So I'm going to enter those in. There's -5 to -2. That's our first interval, and I'm going to be technical about it and use a union. And the other interval is -1 to infinity. Infinity button, again, is right there. Close it off. We're finished with that problem. Okay, I hope you learned something in this video. I'm going to let you get back to it, and let me know if you have any questions.